Hi, I'm Anna, and this is my video for Lab 1 Charged Tapes. For an introduction to this lab, the background was that everyday objects could take on excess negative charges, or they can lose them and become positively charged. The goal of this lab was to calculate the amount of excess charge present on a piece of Scotch tape. The fundamental physics principles I used in this lab were Coulomb's law and the vector electric field. For a short summary of results, charged tape is positively charged, it has a lack of electrons, and the number of electrons lacked by this piece of tape I used was calculated to be 4.09 times 10 to the power of 10 electrons. Some initial data taken in this lab, the length of tape I used was approximately 0.175 meters long. The density of tape given in the protocol was 1 gram per meter. Therefore, the mass of my tape was 1.75 times 10 to the negative 4 kilograms. The height of the floating tape was also observed to be around 0.015 meters. And here you can see a piece of the tape I used, and then the diagram I reproduced from the lab protocol to show how the tape be floated. Some results observations. I found if you bring the two U-tapes together, they will repel each other, as I hypothesized. When you bring the U-tape near other objects that are neutral, such as a desk and a book, it will be attracted to both. Some of the questions I answered from section 7.2 in the protocol. If the U-tape is positive and the charge pen is negative, the U-tape will be attracted to it. But if the U-tape is negative and the charge pen is also negative, it will repel the pen. If the U-tape is neutral and the charge pen is negative, the U-tape will be attracted to the pen. Some final observations. The charge of the tape was determined to be positive because it was attracted to the negatively charged pen after it was rubbed on fabric. Some other results observations. If the momentum of tape B is not changing, then the net force in the y direction is 0. The gravitational force on tape B was calculated using F-grav equals mg. Given the mass from the last slide of 1.75 times 10 to the negative 4 kilograms, F-grav was calculated to be approximately 1.715 times 10 to the negative 3 newtons. And as shown below, the free body diagram with F electric acting in the upward direction and F-grav acting in the downward direction. But since the net force in the y direction is 0, F electric is equal to F-grav. Some calculations. Using the mass of the tape is approximately 1.75 times 10 to the negative 4 kilograms, and F-grav is equal to 1.715 times 10 to the negative 3 newtons. Since we know that F-grav is equal to F electric, it is also 1.715 times 10 to the negative 3 newtons. I use these values to calculate the charge on tape B, since we have the F electric, I was able to solve using that equation for the charge on B, which I found was 6.55 times 10 to the negative 9 coulombs, using a separation distance of 0.015 meters. As for the number of electrons on tape B, this was calculated using the charge on tape B found above, divided by the charge on one electron, which was calculated to be approximately 4.09 times 10 to the 10 electrons. So because the tape is positively charged, this is a deficiency of 4.09 times 10 to the 10 electrons. Some other calculations for the number of atoms on a sticky space of tape was calculated using the tape length divided by the diameter of the atom given in the protocol. This was calculated to be 1.75 times 10 to the 9 atoms. And for the last calculation was the number of deficient electrons to the number of atoms ratio. This was calculated by dividing the number of electrons deficient by the number of atoms, which was found above. This ratio was calculated to be 23.39. As for my code, some assumptions made were to ignore air resistance and to treat the long tape as though it were a point charge with all the charge concentrated at the center of the tape. And this is an image of the code I used to make my calculations. Here's a picture of my VPython model. As you can see, the green arrow is the force electric acting upward, whereas the orange arrow is the force of gravity acting downward, and the blue center dot is representing tape B, whereas the red center dot is serving as tape A. The calculations that VPython did are shown in the bottom image, and as I talked about before, these match the calculations I did myself. Some other questions that were in the protocol. The magnitude of the charge was calculated with the code to be 6.55 to the negative 9 coulombs. If electrons had a positive charge and protons had a negative charge, the results would be the same but opposite observations we made for each case. For example, since the tape was observed to have an overall positive charge, if this was the case, then instead of a deficiency of electrons, it would have an excess of electrons. It is important to handle the charge tape as little as possible so there's no charge exchange between the charge tape and your hand. If the tape comes into contact with your hand or other objects, it is likely it would not work correctly for the next step since charge could have been gained or lost, from the surroundings. All right, that's the end of my presentation. Thank you.